We are on the third question in the workbook that are typical test and exam type questions. Okay, let's jump in. So with the first one there, our instruction with this is to simplify. We are using our basic laws of exponents to simplify these expressions. You need to know that x to the power of 0 gives you 1. So that will give us 7 times 1, which is equal to 7. Common mistake the students make is they just see the exponent of 0 and then they say that this whole expression is just equal to 1. But remember, that exponent of 0 only applies to x to the power of 0. The exponent of 7 is equal to 1. Okay, next up. Again, the instruction is that we are supposed to simplify. Now let's see what is going on over there. We've got that x squared that is being multiplied by, inside the brackets, we've got 3 different terms. We've got term 1, term 2, term 3. Now remember, if we were multiplying, then we could use the laws of exponents to simplify, but there are 3 different terms. So we're going to have to approach this one a little bit differently. We are going to have to use the distributive property. Remember, like if you have something basic like x is equal to, x times x plus 2, for example, and we're supposed to simplify, we would distribute that in, right? Using the distributive property. Okay, now we are going to distribute this in to each term inside the brackets. But we're going to have to be very careful because we have to be mindful of our laws of exponents. So I'm going to write everything out that we're doing and not just do it in my head. So when we multiply the first ones, so the x squared is being multiplied by x to the power of 3. We can do that. If we multiply those two, our bases are the same and we add our exponents. So if we multiply those two, then we get x to the power of 5. Now we're going to have to multiply. So that's the first thing that we did. Then we are going to multiply x squared with that negative 1 over x to the power of 3. Okay, when we do that, well, I'm just going to put that x squared over 1 so that I'm dealing with 2 fractions there. And they are being multiplied. So how do we multiply fractions? Well, a positive times a negative, we know we're going to land up with a negative fraction. We multiply our numerators, x squared times 1, and we multiply our denominators. So that is where we're going to land up. Okay, I'm just going to write that one. We'll simplify it in the next step. So there we are going to land up with that. That is when we multiplied that in. So we distributed that in. Now we're on to the last one where we have to multiply the x squared by x to the power of negative 2. So with our laws of exponents, when our bases are the same and we are multiplying, we are going to add those exponents. So 2 plus that negative 2. So we are going to land up with x to the power of 0 plus x to the power of 0. Okay, perfect. So now we've distributed that x squared in and multiplied it by every single term inside the bracket. Now we can take it from there and simplify a little bit further. X to the power of 5 minus, over there, we are going to land up with x to the power of 1 because I'm going to take my exponent at the top and minus the exponent at the bottom. And then there we will have 1. X to the power of 0 is just 1. Oopsie, that must be a negative 1, I said. Hey, I said negative 1, but wrote that. Okay, so last step would be to just make sure that every single exponent is positive. And there is our final answer. This is different. It will definitely be, or can be, part of an exponent section where the instruction is just to simplify. So maybe this won't show up necessarily when you're just writing an exponent test, but this is definitely something that can show up when you're writing an exam and you've got lots of sections that's part of your assessment. So this is using the distributive property, your laws of exponents, algebraic expressions. Okay, next one. Over here, let's see. Compared to the previous one, this one seems pretty good. There I've got a to the power of 0 that I immediately know is just 1. And then surely we can go simplify those bases. It's still just 3 divided by 6 like you've been doing since you were in primary school. We can simplify that to a half. So at the top, that's going to be 1. That's going to be 1. So I don't even have to write that, but let's just write that for now. And then that would be 2a to the power of 3. These bases are not the same, so we can't simplify that. So what's the last thing that we need to do? We just need to write everything with positive exponents. So at the top, we're left with that 1. At the bottom, those already have positive exponents, so we're not going to move those up. What I see students do is they would, from this step, to make the exponents positive. I've seen it that students then flip the whole fraction to make that one positive, but we can't do that because those already have their positive exponents. Okay, next up. When we look at D, we just see a bunch of brackets, which just means that everything is being multiplied. You don't have to do this, but I'm just doing this for the sake of reminding you that the brackets just indicates that they are being multiplied, but we can also write it like that. Just remove the brackets because it just means that they're being multiplied. But this one over here has the exponent on the outside that we just need to deal with. Remember, the exponent on the outside is multiplied with all exponents on the inside. So there we're going to land up with x to the power of 8 times y squared. Okay, great. Now let's go look for some bases that are the same. I've got bases of x, and our law of exponents says that when our bases are the same and we are multiplying, we can add the exponents. So x, it would be 2 plus 3 plus 8. That should be 13. And then the same for our base of y, and y, there's just a 1. So it would be 1 plus 2, which is just 3. So we dealt with those bases of x and y. There's just a coefficient of 1. And if we multiply the -3, -2, and the +1, that will give us +6. And there we're done. All right, let's see what's going on with this one. Well, what's interesting there is we've got a fraction as an exponent, but don't feel, this is going to be hard when you see something like that. We just do what we normally do. What we also see is our 0 exponent there, which means that that whole bracket will just become 1. Because, we know that we multiply, that we multiply the exponent on the outside by all exponents on the inside. So it is just going to give us 1. We don't even have to show that, but you can if you want to. So we know that that is going to give us 1 that is being multiplied by. The same thing applies, even when your exponent on the outside is a fraction. We multiply the exponent on the inside by the exponent on the outside. So we've got x, and then we've got 3 times -1/3, and that should give us -1. That is just your fractions, grade 9s. That will give you -3/3, which is equal to -1. Then we've got 9 times -1/3. So 9, I'm just going to put it over 1, that both are fractions. That should be the other way around. 1/3. So that gives us -9/3, which is equal to -3. So y to the power of -3 times 1. That's it. Now, we're not done yet because we need to give all our exponents there with a positive answer. So that will give us 1/x to the power of 1. I don't even have to write that. And then y to the power of 3. They both had negative exponents, and now they both have positive exponents. Okay, this one seems like it's got a lot going on, but let's just do it step by step, break it down. All these brackets are raised to a power. So we've got that one that we need to deal with. We're going to do it step by step, and then we need to do the same in the denominator as well. So let's do that. For the first one, for the orange bit there, remember, we're not going to multiply an exponent with the base. It's not going to be 2 times -1. we multiply the exponent on the outside by the exponents on the inside. So that's what we're going to do. So then we're going to land up with 2 to the power of negative 1 times a to the power of negative 1 times b to the power of negative 2 times c to the power of negative 1. And then that's been multiplied with, for the yellow bit, 2 to the power of 2, because remember the exponents, and then times a to the power of 6, b to the power of 4. So there we've gotten rid of those exponents in the numerator. Let's do that green bit at the bottom. So again, the exponents on the outside, or the exponent on the outside, gets multiplied with every single exponent on the inside. So that would be 2 to the power of negative 2, a squared, b to the power of negative 4, and then c to the power of 0 times 2 is just 0. Okay, we've got a lot of negative exponents there at the top. Don't worry about it now. We just need to make sure, grade 9s, that our final answer doesn't have a negative exponent. But as we're working and simplifying, it's okay if we've got some negative exponents there. Now, how you proceed from this point, it doesn't have to look exactly like mine. It needs to make sense to you, and obviously it needs to be mathematically sound. But let's see what we can do. I have got a base of 2 and a base of 2 and a base of 2 there, so we can definitely work with that. Let me actually also just use highlighter here. So there we've got base of A, base of A, base of A, and there we've got base of B, base of B, base of B, and then we've got base of C and base of C. Let's deal with the numerator first, where we simplify the numerator. Okay, for our bases of 2, and our bases are the same, the base stays the same, and we add the exponent. So negative 1 plus 2 will just give us 1, so we don't even have to write that. For A, our base stays the same, and it will be negative 1 plus 6, so that is going to give us 5. For our base B, negative 2 plus 4 will give us positive 2, and then C minus 1 just tags along. There isn't a base to put it together with. Now, for the denominator, I'm just going to write this over like that before we start simplifying it. I'm just going to, c to the power of 0 is just 1, so I'm not going to write that over. Okay, now we are dividing and we are looking for those similar bases again. So C doesn't have a similar base there. We know that B has got that similar base, so we can simplify that further. And then obviously we've got our base of 2. Let's start with 2. Could you have also worked out, evaluate that to see what 2 to the power of negative 2 is and divide that? Sure. But I'm just going to use my laws of exponent because my bases are the same. So for my base of 2, my base stays the same, and I take the exponent at the top and I subtract the exponent at the bottom. I take the exponent at the top and I subtract the exponent at the bottom. I'm subtracting something that's already negative, and that is why we got that going on. Okay, then for my base of A, I take the exponent at the top and I subtract the exponent at the bottom. And then for my base B, I take my exponent at the top and I subtract my exponent at the bottom. And then I've got my base C, which is just the same. Okay, so there's my next step. We need more space. Okay, so let's simplify that. So that will become 2 to the power of 1 plus 2, which would be 3. Then we've got a to the power of 5 minus 2, which is 3. B to the power of 2 plus 4, which is 6. And then C to the power of negative 1. One more step. We can evaluate that because we actually know what that is, and we don't want a negative exponent there. 2 to the power of 3 will be 8. And to get a negative exponent, we will just flip it, and that becomes a positive 1, which we don't actually have to write. And finally, we are done. This is long. You have to concentrate to avoid just silly areas creeping in there. But if you do it step by step, you just apply your laws, I know that you can do this. And if you did it on your own, I hope that it went really well. Okay, last one for question 3. Let's see what's going on. Okay, so we've got bases of A and B. We've got an n in the exponent. Okay, let's just think. Our laws of exponents says that if our bases are the same and we are multiplying, we can add exponents. And we definitely have bases that are the same there. So we've got base of A, and we've got base of B. There's another base of A. Okay, but first we're definitely going to have to do with those brackets. So let's do that. Our law of exponents says that if we've got an exponent on the inside of a bracket and it is raised to another power, we're just going to multiply those. So it will become A times, now I'm lying, A to the power of 4 times n plus 1. Times over here. That exponent needs to be multiplied by that exponent and that exponent. So that's going to become A to the power of negative 6 times B to the power of negative 3. For the denominator, that's got an exponent of 1 and an exponent of 1, so that will become A to the power of negative 2n times B to the power of negative 2n times B to the power of negative n. Nothing we had to do there. Okay, great. So far, so good. We dealt with those brackets. Don't freak out because of that. We just applied the law. We took the exponent on the inside and we multiplied it by the exponent on the outside. Now, let's take it from there. Well, we've got a base of A there and a base of A there. Let's simplify the numerator on its own and the denominator on its own, and then we see what we can do from there. So we've got those bases of A. So our laws of exponent, or our law of exponents, says that if our bases are the same and we are multiplying, we can add those exponents. And if we multiply that in quickly using the distributive property, we're going to land up with that. So we're going to have A, and then in the exponent, 4n plus 4, and then plus that minus 6, right? So we are going to land up with 4n, take away 2, because we've got 4n plus 4, and then minus 6, right? So if we simplify that, so we simplified our bases of A, we put them together, and there we still have that situation. For the denominator, we just leave that one like that for now. And there are our bases of B that are the same. So our base stays the same, and we will add those exponents. So it will be negative 2n plus negative n. So that will become negative 3n. Okay, we're almost there. Now we are dividing, and we've got bases that are the same. So when we are dividing and our bases are the same, we are going to subtract our exponents. Let's do that carefully. Our base stays the same. The exponent at the top, there it is. Subtract the exponent at the bottom. So we are subtracting something that's already negative. And then for B, negative 3. And then we subtract the exponent at the bottom. So we've got that. And we subtract something that is already negative. Sure. Okay, let's show all our steps. So we've got A, 4n minus 2, and that will become plus 2n, right? And then we've got B to the power of negative 3, and then that will become plus 3n. Our integers, almost there. Let's simplify that. So that will become A to the power of 4n plus 2n will be 6n minus 2. And then that will be B. I'm just going to change that order. We don't have to, but I'm going to. And then there's nothing else that we can do. Those bases are not the same. We are done. Sure. This was a tough question. Question 3 was a tough one.